All right. Today I'll be going over how to conduct a latent profile analysis in R. Got all of my code set up here. Let me go ahead and clear that. I've got it set up into three different parts. So LPA1, LPA2, and LPA3. And I'll be going through all those individually. First off, I guess let's take a look at the data set that I have. So I'm going to run this line, this read Excel line, just to pull my data set so I can have it up and refer to it a little bit more. So I guess I'll just go into what latent profile analysis is. What it is it's a clustering procedure that uses uses continuous variables to cluster data into different groups, with the idea that these groups are subgroups of an entire population, and so that two populations are better described, or that a single population is better described by a group of multiple populations that are more like each other. So we're looking at groups that are hidden in a population that are homogeneous, are more homogeneous with themselves than the entire population. Um, so in order to do that, of course, we need continuous variables. So I have this LPA data here, and this is a data set of students ranking what they thought about their university. So we've got cost of university, atmosphere, the info and information about scheduling that they have, and the characteristics of the courses. And that was ranked on a 1 to 5 scale, so continuous data. And it's actually an aggregate of multiple items, so that's why we see things like 2.11, 1.22. It's because it's the average of across multiple items. This is not actually just a one item question or whatever. Um, but anyway, yeah, let's get into the code. Of course, up here I've got all of these libraries. I've got tinyverse and yeah, so tinyverse is kind of like it's going to be used to make our graphs. Sorry. And then we've got our clustering library, mclust, HRBR themes, which is another thing to help us put things out into the plot thing, readxl, which I already used, and for cats, which is a tool for utilizing categorical variables. Basically, what this code is it's a bunch of different steps that actually make functions in R that can be reused. And the for cats library is useful in making some of those functions. I want to give a quick shout out to Joshua, whose last name I have written over here, Joshua Rosenberg, who I adapted most of this code from. So thank you, Joshua Rosenberg, for exploring the world of LPA and R so that we can learn. So anyway, we're going to start off by, we already have our Excel file in, so I'm just going to push our Excel data into this df variable, which we're going to use in our function creation. And then we're going to calculate a BIC, which is the indice we're going to use to see how our models fit. Let's go ahead and run these. Yeah, and this is the actual the clustering part. It's basically taking all of our data and clustering it in a bunch of different models, which are going to be plotted. So now we can see that pop up right here, and then we have a summary up here. So this is giving us the top three, or really the bottom three, because you want low BICs for a good fit. The bottom three functions, or rather formulas that were computed and their kind of descriptions. So these descriptions kind of pertain to like the description of the model. And as you can see, there's like a bunch of them, and we don't really care necessarily about all of them, or at least I don't care about all of them. But this is just an option that you have if you do care about all of these different types of variables. But I'm going to make this explore model fit function that talks about particular cases that I care about. Specifically, we're going to look at cases of constrained variance and fixed covariance, uh, a case of free variance, fixed covariance, a case of constrained variance and constrained covariance, and a case of free variance and free covariance, just so I don't have so many models mixing up here. And you can see that those models do exist in this graph, but I just want to see only them. So that's what this set of code is going to do. It's going to create that function that allows me to do that. You can see that um, the maximum amount of profiles, or rather the maximum is 9 and the minimum is 1. This is going to be the range. That's what determined, it's going to determine what basically this x-axis is on the models. And we're only going to be pulling these 4, which correspond to these, like I said. I don't know if this works on YouTube. I think it does on Screencast-O-Matic, but I don't think it does. Okay, let's go ahead and run it. So now all that did was create a function, which is going to be useful, but we don't actually have anything in that function yet. So I'm going to actually run the new function that we just had based on that df value that we established earlier. So it's basically doing what we just did, except using our new function, and we're only interested in 1 to 6 components. We don't need to go all the way up to 9. Okay, cool. Now R stored that information for us. So now we just need to plot it. That's what this is going to do. Or rather, this is formatting it so that we can plot it. It's just formatting it so that the plot will look nice and pretty, basically, and give us the correct labels that we needed. Because again, like when we made this, we made our own function. We were basically renaming these structures, the descriptive structures, to this new thing. So we just want that to show up on our plot. So that's what that's doing. Now we can finally plot it. Boom. There is our graph. Kind of similar to the one we had before, but a lot less lines. You can see clearly labeled about which line is what. So from here, we can see that the lowest BIC, which is what we're looking for, is bam right here. So it's a 3 profile solution with free model of free variance and fixed covariance. So that's the one I'm going to pick. Note that, kind of like in k-means cluster analysis, which we learned earlier, that this is kind of a crapshoot in terms of picking which one it is. I talked about in my paper about how the actual modeling of this has a rhyme and reason, in that we're actually creating functions that make sense in order to cluster things, but picking out which model you want to use is still a matter of interpreting things. So we want to keep that in mind, but we'll take a look at this one since it has the best fit indices. So now we're ready to move on to part 2, which is starting to look at the model. So I'm going to actually start a new video for that part. All right, so we're back and we're going to cover the next 2 parts. The LPA2 code up here and the LPA3 code up here. Basically what we're doing is creating that model that we decided we wanted to use we decided that we wanted to use the free variance fixed covariance model, and that we were going to do 3 different profiles because that seemed to fit best. And so this is going to help us do that. Basically, this LPA2 part is creating this new function called profiles, create profiles mclust. It's going to identify what the variance and covariance structures are, and then label them accordingly. So again, we see these I, E, E, I, V, V, I, E, E, whatever we're interested in is freed variance and fixed covariance. But what's cool about this profile is that we're not just making this function to serve our particular set of data, because obviously then we would just go with this part of it here, the freed and fixed. This is gonna accommodate for all of the 4 profiles that we did originally. So if we wouldn't have to recreate this function if we wanted to perform this again, and it would show up with the model that would be best. Cool. So that's what basically all of this part does. This is just taking that information and putting it into one variable, and then this prints out the information that we gathered and puts it to the console. So let's go ahead and run all that. Cool. A bunch of stuff happened, and we have a new function. And print. Not sure what's going on here. We should be getting something to the console.